Welcome to this explainer. You know, if you look at the trajectory of human civilization, our greatest achievements and our most profound crises have both been forged in exactly the same place, our cities. And right now, we're standing at a pretty critical juncture. Today, we're going to break down the absolutely mandatory transition from the struggling, overburdened modern cities we see all around us to the meticulously planned, sustainable cities of the future. We'll examine the actual anatomy of this transformation, really getting into how a city can thrive without, well, devouring its own foundation. All right, let's dive right in. Here's our roadmap for today. We'll start by looking at the specific challenges of modern cities, define what an eco-city actually is, and then explore its three core pillars: sustainable mobility, resources and energy, and community living. Finally, we'll tie it all together by visualizing these concepts in Amaravati. Section 1. The challenges of modern cities. Let's take a minute to really consider the immense pressure our urban spaces are under right now. To solve a puzzle this big, we first have to break down the problem. And honestly, the urban crisis is incredibly multi-layered. First up, infrastructure. The massive demand for buildings and roads leads to congested transportation, struggling sanitation systems, and the really complex issue of managing slums. Then think about resources. Cities have this insatiable appetite for fresh water, energy, and food, which directly results in colossal waste management issues. And finally, all these pressures snowball into severe environmental and societal challenges. We're talking environmental degradation, the overarching threat of climate change, and even serious strains on law and order. It's basically a massive interconnected web of systemic stress. Section 2. Defining the eco-city. Because just tweaking our current system, that's not going to cut it anymore. We need a fundamental paradigm shift. So what exactly is the goal here? Well, a sustainable city, often called an ecological city or eco-city, is defined as a settlement designed to have as little impact on the environment as possible. I really want to emphasize that phrase, as little impact on the environment as possible. This isn't just some feel-good ideological goal anymore. It is the strict baseline metric against which all future urban engineering, architecture, and resource management literally has to be measured. Section 3. Sustainable mobility. Think of this as the city's circulatory system. And this setup right here brilliantly illustrates the concept in action. Notice the elevated multi-layered transit system integrating seamlessly into the skyline? For a city to truly be sustainable, public transport has to be elevated from just a secondary option to a primary, highly attractive alternative to driving a car. It takes heavy engineering and serious investment to create these dedicated, frictionless pathways for mass transit that completely bypass standard road congestion. If we break it down, sustainable mobility really hinges on three absolute must-haves. First, public transport must be safe and reliable. Because let's face it, if a train is always late or feels unsafe, people are going to jump right back into their cars. Second, it has to be a genuinely viable alternative, meaning it's economically and geographically accessible for everyone. And third, the city has to prioritize safe walking and cycling networks. The infrastructure needs to protect a pedestrian or a cyclist just as rigorously as it facilitates a commuter train. Section 4. Resources and energy. We're shifting gears now from how the city moves to how it's powered and maintained. Now, this is a massive conceptual flip. In a traditional city, waste is an endpoint, right? It's a costly burden. But in an eco-city, waste is structurally viewed as a resource, and it's recycled wherever possible. This is the absolute foundation of a circular urban economy, and it's key to drastically reducing that environmental degradation we talked about earlier. But it goes way beyond just recycling. Mitigating a city's environmental impact requires incredibly strict resource management. The city has to mandate the use of renewable resources over non-renewable ones wherever humanly possible. Plus, we have to curb demand right at the source. This means new homes must be engineered from the ground up to be energy efficient. By lowering that baseline demand for power, the city shrinks its carbon footprint and fights climate change head-on. Section 5. Community living. Because at the end of the day, a city isn't just concrete and power grids, it is an ecosystem of human beings. We call this social sustainability. Look, an eco-city completely fails if it only serves a privileged few. Resources, services, and social amenities have to be accessible to all residents. There must be guaranteed access to affordable housing to prevent the crises of urban slums. On top of that, open spaces need to be designed so they are safe, accessible, and actually enjoyable to be in. Ultimately, you need strong community links, fostering an environment where neighbors work together to proactively handle crime and security. Section 6, Visualizing Amarvathi. Let's see how all these theoretical pillars actually translate into a real-world master plan. What's really fascinating here is how theory becomes actual geometry. If you look at the layout, you can see the integration of the built environment with dedicated transit corridors and waterways, meaning sustainable mobility is baked right into the city's DNA. And notice the organized circular green block layouts? That design directly supports the social sustainability we just talked about. It mathematically ensures that affordable housing, amenities, and safe open spaces are a short distance away for every single resident in that hub. Zooming out to a wider topographical view, we can see the critical intersection of human infrastructure and natural resources. The proximity to the river and that massive dam structure really highlights the staggering demand for fresh water a city has. A design like this attempts to respect the region's natural hydrology. It's trying to balance the immense thirst of the urban center with the ecological health of the river basin, treating fresh water as a precious, renewable resource that has to be protected. And finally, when you look at this comprehensive scale model, the sheer complexity of an eco-city just hits you. You can see exactly how mobility networks, resource grids, and community zones all have to lock together perfectly. You can't really retrofit this kind of eco-city easily. It demands this extreme level of macro planning from day one. Every single road, waterway, and residential block has to work together to minimize environmental impact while maximizing the quality of life for the people living there. So, we've walked through the anatomy of a sustainable city, from the initial urban crisis straight through to solutions in mobility, energy, and community equity. But I want to leave you with something to chew on next time you step outside. Take a look at the roads you drive on, the energy your building consumes, and the public spaces you use. How does your own city's infrastructure actually measure up against these pillars of a sustainable eco-city? Thank you so much for joining me in this explainer, and keep questioning the design of the world around you.